Warning: sulfuric acid and hydrochloric acid are corrosive. Hydrogen chloride is irritating. Wear gloves when handling them and work in a well-ventilated area. Hi guys, here is MIH. This is the third video about making hydrochloric acid on this channel, and I know it's boring to watch me make the same chemical over and over again, but I'm using a better method every time. Today's method is one of the most classical ones, reacting sulfuric acid with a chloride salt. In my case, battery acid with ammonium chloride. Now I know the battery acid kind of defeats the purpose of this whole 3-acid series, where my aim is to make all the acids without buying them, but after trying a bunch of different methods on making sulfuric acid, I gave up and bought the battery acid. It was really too much work making it myself, and I have to use it for almost any occasion, so I need a good supply of it. Anyways, we start by building a distillation apparatus in the exact same way as my nitric acid and my dichromate video. Actually, you know what? I probably should give this specialized apparatus a name. Maybe the MIH style fancy condenser or something like that, whatever. I then measured out around 140 grams of 37% sulfuric acid into a 500 ml conical flask and added 53 grams of ammonium chloride into it. This is a 1 to 2 molar ratio with a slight excess of sulfuric acid. The flask was then placed on the hot plate and heated. The amount of water in the flask is calculated to be just enough to dissolve everything at boiling, which is why I didn't add extra water. After 5 minutes, our first drops of acid started coming over. It is colorless, which is an awesome sign. The mixture then begins to boil vigorously. As you can see, everything dissolves, and the acid boils fine even without stirring. The acid is steadily dissolving over and condensing the condenser, and I always find watching the vapors condensing to be a cool thing. The exhaust trap filled with water is also releasing some bubbles, but most of the gas gets absorbed in the water without bubbling out. I lifted the tube out of the water, and you can immediately see the white hydrochloric acid fumes releasing from it. As the distillation continues, I found that my plastic collection bottle was somehow leaking some acid vapors out of its joints, but a plastic bottle is all I got, so I can't switch to a glass one. Soon, the acid in the condenser is about to flow into a receiving bottle. The moment the acid flows into the tube, a lot of bubbling occurs, and you can see the acid flowing back and forth. This is because the whole apparatus was filled with hydrogen chloride gas, and when the acid blocks its way, it dissolves into the acid vigorously and rapidly decreases in volume, making the acid backflow. The exhaust trap was also backflowing a lot due to the decrease in volume, so I pulled out the tube out of the beaker to prevent that. However, some hydrogen chloride was released from it, so I set the tube barely touching the water to limit the amount of water that backflows while still absorbing all the hydrogen chloride. The distillation is quite fast, and after an hour only some brown tar-like liquid was left in the conical flask. This is molten ammonium sulfate mixed with sulfuric acid and ammonium chloride, which I'll recover later. A decent amount of hydrochloric acid is collected in the condenser and in the plastic bottle. The apparatus was then allowed to cool down and taken apart, and you can see the solidified cake of ammonium sulfate cracking as it cools and shrinks. The cake is yellow due to impurities sticking on the flask from the last experiment. I smashed the cake into pieces and got it all out from the flask, and it weighs 77.1 grams, which is slightly more than the theoretical 70, but there are still some water inside it. I then poured all my hydrochloric acid into a storage bottle, and its mass is 150 grams, which is much higher than the theoretical 125, so there are definitely some water backflowing from the trap that ended up in there. I then took a sample and measured its volume and density, and the concentration turns out to be 15.3%, which is a lot lower than expected. I don't really trust this number though, because the reaction is rather complete as far as I can tell, and the acid is slightly fuming in air, so I expect it around 20%. This gives us a yield of 82%, which is decent, and remember that there is still more acid in the scrubber, so I'm pretty satisfied with the efficiency of this method. I then recovered the ammonium sulfate from the cake by adding an equal amount of water. The cake dissolves quickly on heating, and when the solution cools down, some beautiful crystals formed, which I filtered off. The filtrate was boiled again until almost no water remained, and a second crop of crystals is harvested from it. The ammonium sulfate produced will be used to make ammonium alum crystals and ammonium persulfate in the future. See you soon!